right, so I've created a quick lesson on solving quadratics by completing the square. This one is important. It will be used next year in geometry. So I do want you to make sure you watch through here and look at how we complete the square to solve our quadratics. All right, so remember that we talked about what a perfect square trinomial looks like. So this is on your star chart. But we've talked about it has to be a trinomial where the first term is a perfect square, the third term is a perfect square, and then that middle term is either plus or minus, depending on 2 times the square root of the first term times the square root of the second term, 2ab. All right, so for this method, what we're going to be doing is we're going to be basically given these 2 terms, and we have to find what this third term is. We have to discover what this constant we need to add, this b squared, if you will, needs to be to complete it, to make this a perfect square. So that's why it's called completing the square. All right, so the reason we want that is because if I have a perfect square trinomial, then we can factor it. Right? We can factor it into a plus b squared or a minus b squared. All right, so let's start with a little example, and I'll kind of walk you through this. But if I have x squared plus 6x equals -2, what I want to do is I want to take this binomial. I have x squared plus 6x, and I want to figure out what can I add here to make it a perfect square. All right, so I know that if I add 9, it will be a perfect square. And we'll talk about in a minute how to figure that out and make that easier for you. But if I add 9 to this binomial, now I have a perfect square trinomial of x squared plus 6x plus 9. Now make sure that if I add that, whatever I add to make it a perfect square, I also have to come over and add that to the other side of my equation. It is still an equation. So if I can't just add 9 to the left and go on about my way, I have to then make it balanced and add 9 to the other side. This is probably the most common mistake. All right, remember, we are talking about an equation. So if I'm going to add 9 here, I need to add 9 to the other side. All right, so now I'm going to simplify both sides. I'm going to take my perfect square trinomial and I'm going to factor it. I know that it is the same thing as x plus 3, the binomial x plus 3 squared. All right, and that's why we do that, because we want to be able to go here. All right, and then on the right side I have -2 plus 9, which gives me a positive 7. So now I have written my equation so that I can solve using square roots. All right, so I can take the square root of both sides so that I have x plus 3 equals 2, the positive or negative square root of 7. All right, then I'll subtract 3 on both sides, and we end up with x is equal to -3 plus or minus the square root of 7. So there are my 2 solutions, -3 plus root 7 and -3 minus root 7. All right? So adding 9 to x squared plus 6x had the fortunate result of making the expression a perfect square trinomial. Okay, so that we could then factor it into x plus 3 squared. All right, so this allowed us to solve it by taking square roots. Okay, this is not just a coincidence, right? We had to use 9, right, in this example in order to make it a perfect square. All right, so to create a perfect square, all right, what we need to do is we need to think about it as standard form. All right, so I need to take half of the b value, whatever the coefficient of my x term is, and then square it. That will create our c term. So, in other words, this is what we started with, x squared plus 6x. All right, so the b value, the coefficient of the x term, was 6. So we want to take half of that b term, right? And the reason is because that middle term, remember, in a perfect square, 2ab, right, has a 2. So we're going to divide out that 2. So we'll take half of the b term, and then we need to square it. All right, so 6 divided by 2 is 3. 3 squared is 9. That gives us the constant that we need to add to create a perfect square. All right, so we need to do b divided by 2 and then square it, okay? That will give us our constant. All right, so as you just saw, we can add a constant to the expression x squared plus bx to form a trinomial that is a perfect square. This is called completing the square. So that's what we're doing. We're completing the perfect square. All right, so let's do some examples, just figuring out what we need to add to complete the square. So if I have x squared minus 18x, and I'm looking for that constant, we need to take, notice my b value here is negative 18, the coefficient of the x term. So I need to take half of negative 18, and I need to square it. So negative 9 squared is 81. So 81 is what I would need to add. And remember, I would add that to both sides once I have an equation. So plus 81. Then what could I factor this to? This would be x minus, because my middle term is subtraction, x minus 9 squared. All right, x squared plus 12x plus what? So I'm going to take half of the b value, so half of 12, and I need to square it. So I have 6 squared, which is 36, so I'm going to add 36. Now I have a perfect square trinomial, but we would add 36 to both sides in our equation. So I have x plus 6 squared when I factor it. All right, so now not every b value is nice and even, right? And if I have to divide it by 2, it may not come out pretty, but that's okay. Still works. All right, so I still want half of my b value, so I want half of 11, and I'm going to leave everything a fraction. So it's easier just to work with the fractions because sometimes your decimals get really gross. So half of my b value and square it. So 11 halves squared is going to be 121 fourths. And I would add 121 fourths to both sides. Okay, and then when I factor this, I will have x plus 11 halves squared. All right, so now we're going to solve by completing the square. So I've gone ahead and set this up where I've got my x squared and my x term on the left. My constant is on the right. And I'm going to see what I need to do in order to make it a perfect square. All right, so half of negative 10. Oh, ahead of myself. Half of negative 10 squared. So I need to do negative 5 squared, which is 25. So I'm going to add 25 to both sides. All right, make sure that you add it to both sides of your equation. Again, this is the part that is almost always forgotten, or the most common mistake is to forget that you have to add it over here or it doesn't work. All right, so now I have my perfect square trinomial, which I'm going to factor. This will become x minus 5 squared. And then negative 12 plus 25 is 13. Right, so if I hadn't added that 25, I'd have negative 12 over here, and then it wouldn't work. So make sure that you do that. All right, so now I'm going to take my square roots on both sides. All right, so root 13, remember we have the positive and negative root of 13. So x minus 5 equals positive or negative root 13. Then I'm going to add the 5 to both sides. So I end up with x is equal to 5 plus or minus the square root of 13. So there are your two solutions. X plus the square root of 13, 5 plus the square root of 13 and 5 minus the square root of 13. All right, and again, be sure to add 25, whatever that constant is, to both sides. All right, so here's a little summary if you want to pause and jot down the steps. We do want to get our equation into this form first. So go ahead, if there is a constant, move it over to the other side. So I'm going to do that in the next example. But we want to start with our x squared and our x term on the left and our constant on the right. Okay, then we'll do half of b and square it. That will tell us what we need to add to both sides of the equation. All right, factor the perfect square trinomial, take the square root of both sides and solve. All right, when completing the square, if your a value is not 1, so all the ones up to this point, it's just been x squared. All right, so now I've got a 3x squared. So if I'm going to solve this by completing the square, let's get our a value equal to 1. So I'm going to divide everything by 3 so that I have just the x squared. Now sometimes this will end up with some nasty fractions here, but that's okay. You can work with them. So I have x squared plus 2x minus 4 equals 0. So if I'm going to solve this by completing the square, okay, then I want to go ahead and I want to move this negative 4 out of the way. I want to get it over to the other side. I think that's the easiest way to go about it. Okay, so I have x squared plus 2x, I'm going to leave some space, equals 4. Now I'm going to look for what I need to add to complete the square here. All right, so my b value is 2, so half of 2 squared. So half of 2 is 1, 1 squared is 1. So I'm going to add 1, and I'm going to do it to both sides. All right, so now I have a perfect square trinomial here. I can factor this. This is x plus 1 squared equals 5. Okay, if you forgot to add that 1, then you don't have 5 over here, so be very careful. Take square roots. So I have x plus 1 equals the positive or negative square root of 5. And then I solve for x by subtracting 1. So come up here. So x is equal to negative 1 plus or minus the square root of 5. So negative 1 plus root 5 is one solution, and negative 1 minus root 5 is my other solution. All right, so I hope that made some sense. It does take some practice. So if you want to go into your Khan or your IXL accounts and work on the completing the square, I highly recommend it. Make sure you're adding to both sides. Make sure you're doing half of b squared. So anyway, I hope that helped, and I hope you're having a good day, and I'll see y'all later.